All right, hey, welcome to this video. We're going to be looking at linear patterns, and the most specific linear pattern that we're going to be looking at in this course is called an arithmetic sequence. It's a special type of linear pattern where you are just given a list of numbers and you're either adding or subtracting to get the next term in the sequence. In this case here, let's take a look at this first one. What is the next term in the arithmetic sequence? And then it gives us 9, 15, 21, 27. And as I look at this, I just want to find out, what am I doing to get from one term to the next? So going from 9 to 15, well, I'm adding 6. From 15 to 21, I'm adding 6 again. From 21 to 27, I'm adding 6 again. So if I want the next term in the sequence, I'm going to add 6 again. And 27 plus 6 gives me 33. That would be my next term in the sequence. But what if they're not asking for the next term in the sequence? What if they're asking for the 10th term in the sequence? Well, as we saw, we can add 6 again to get 33. We can add 6 again to get 39. Add it again to get 45. All right, we can add it again to get 51. And we can count to see where we're at now. We're at 1, 2, 3, 4, 5, 6, 7, 8. So not there yet. 9 would be 57. And then 10, I'm running out of room here, but 10, if I added to that, I would get 63. So that would be my answer. 63 would be the 10th term in this sequence. And that's a great way to do it. It worked out fine. I got there because I can just keep adding 6. Pretty simple. All right? But what if they ask you something like the 78th term? Oh, well, you could list out to 78 if you want to, but what if they ask you for the 102nd term? All right, the 327th term. Now, all of a sudden, we're getting to a point where just counting alone would be a cause for mistake. So we got to find a different way to do this at this point. There's got to be a quicker method, and there is. An arithmetic sequence is what we've been working alongside with patterns this entire time. All of our patterns that we've been seeing have indeed been arithmetic sequences. Take a look at this one. How many tiles here in figure 1? There are 9. How many tiles here in figure 2? 15. How many tiles here in figure 3? 21. All right, does this pattern look familiar to you? 9, 15, 21. Let's take a look. Look at this pattern. Here it is. Figure 1 had 9 tiles. Figure 2 had 15. Figure 3 had 21. Figure 4 has 27. So how many tiles do we think are going to be in figure 4? 27 tiles. All right, and we noticed that they were adding 6 tiles every single time. And what did we do with these tile patterns? Well, we absolutely did not draw the 10th figure. We did not draw all the figures or build them online all the way out to 78. Instead, we used what we knew about the slope and the equation for a linear equation in order to figure out the equation of this pattern. And to remind us of that, let's take a look at our formula sheet for Algebra 1. Here's your formula sheet. There's not much on here that will be used throughout the whole year, but there are certain things where they don't want you to memorize. And if you keep coming down here to linear equations, down in this section right over here, you will see the equation that we've been working with, our slope-intercept form. And as we deal with that slope-intercept form, I'm going to give myself a little bit more room. I'm going to remind us of what those pieces are. So y equals mx plus b. We know that m represents our slope, all right, and b represents our intercept. That's why it's called slope-intercept form. Now, which intercept is it talking about? It's talking about the y-intercept because we start with y equals. All right, so it's the slope-intercept form. Some reminders about our slope. Our slope of reminder is right here. It is equal to m, which should remind you, because there's m, so it reminds you that m represents my slope. All right, and in this case it says y2 minus y1 over x2 minus x1. That's another way to say change in y over change in x. And remember, this little triangle symbol, this delta, all right, for Greek, represents the words change in. That's what the triangle represents there. So what is it changing in per y? Well, for our arithmetic sequences, our change in x being our figure number, is always 1 in this case. All right, so that's why our change in y, what we're adding or subtracting per tile pattern, all right, is going to represent the slope itself. It's just going to be what is added or subtracted per term. I'll write per, like that. Per term. All right? My y-intercept, however, my y-intercept, you want to think that's where we start, but the first one they gave you was not the starting point. All right? Our starting point, our y-intercept, is always when x is 0, comma, and then it's our b value. All right? So when x is 0, in other words, figure 0. All right? So this b value is the number when x equals 0, or figure 0. So that's what we got to find, and that's the piece here that they do not give to us. So let's take a look back here, and that's why I have this figure 0 written over on the left over here. What is figure 0? How many tiles would be in figure 0? Well, I know that if this pattern is consistent, I'm adding 6 every single time, which means I added 6 from figure 0 to get to figure 1. So the question that I'm really asking is, what plus 6 is 9? Well, the answer to that question is 3. All right? And therefore, using these two pieces of information, my figure 0 value and what I'm adding and subtracting each time, I can get my equation for this. All right? I can find my equation to be y equals 6x plus 3. 6 being the increase, my slope, what I'm adding or subtracting each time, and 3 being my starting point, my figure 0, or term 0 when we get to an arithmetic sequence. So let's see what that looks like here. Now, same thing. I'm just going to figure out what I'm adding, which we already said was plus 6. All right? So therefore, I know my equation starts with y equals 6x. All right? What I'm increasing in my pattern is my rate of change, also known as my slope, and that goes in front of x. And then I have to ask myself, where would it have started if I'm continuing this pattern all the way through? What is this value right here? And as we said, what plus 6 is 9? Well, 3 plus 6 is 9. And since it's a positive 3, I'm going to put plus 3 in my rule. All right? Now, the purpose of getting this rule is I can take whatever value they give me, 78th term, and I can plug it in for x, which represents our terms. Y is the value of the term, but x represents our term. So I can just say that y equals 6 times 78 plus 3. And you can take your calculator and you can just plug it straight in. And you will find that y in this case is equal to 471. In other words, the value of the 78th term is 471. And I'm glad we didn't write numbers all the way up to 471. Now, let's put this into practice with a few more examples. All right, now on this one here, I want you to try and pause the video, see if you can figure out the 32nd term on your own by writing the equation for this one. Now that you're coming back into it, I'm going to assume that you already got your answer. Let's see if you're right. First thing I'm going to do is find out the increase each time. What am I adding or subtracting? In this case, 7 plus 4 is 11, plus 4 is 15, plus 4 is 19. So my equation is going to start off with y equals 4x. Now, where would I begin? Well, what plus 4 is 7? Well, 3 plus 4 is 7. So once again, a plus 3 is what we're starting with. And now I can take 32 and plug it into my rule. So we're going to find out y equals 4 times 32 plus 3. And I get 131. All right, 131 is my 32nd term. Let's try another one. All right, what is the 25th term in this sequence? Again, pause the video. See if you can get it on your own. All right, now I'm assuming that you paused it. And as we look here, we're going to find our increase or decrease first. And this time I'm going down 2. Down 2 every single time. So my rule is going to start off as y equals negative 2x. Where would I begin? All right, if I was going down 2, well, what minus 2 is 36? Well, 38 minus 2 is 36. So now I can take 25 and plug it into my rule. And then go ahead and plug that into your calculator or work it out by hand, and you should find that the 25th term is negative 12. All right, so negative 12 is the value of the 25th term. Let's try another one. All right, again, pause the video. See if you can figure it out. All All right, in this case here, find out what we're increasing or decreasing. As I look here, going from -7 to -4, I'm going up 3, up 3, up 3. So I know that my equation is going to be y equals 3x. And where would I begin this pattern? Again, we always got to go back to term 0. If I added 3, what plus 3 is -7? Well, -10 plus 3 is -7. And therefore, 3x minus 10 is going to be my rule. Notice, since it's a -10, I put minus 10. Take 108, plug it in, and plug it into your calculator, and you should get 314 if you did that correctly. So the 108th term is 314. Let's do another one. All right, again, pause it, see if you can figure it out on your own. All right, in this case here, my increase or decrease, if I were to find it, I'm going down 13 every single time. Down 13. All right? So in this case here, I go y equals -13x. So then you got to figure out, once again, where would I begin? What minus 13 will get me down to -2? It's going to be somewhere in the positive. If that's a little bit harder to think about. If you wanted to work backwards, you could go -2 plus 13 to figure out that it's 11. All right, 11 minus 13 is -2. So you can always do the opposite to go back in these ones that are a little bit more challenging. All right, so we find out here is positive 11. So I'm going to add 11 to my rule as my starting point. And what is the 11th term? So I'm going to plug 11 in. Don't confuse the two 11s. It's just a coincidence. All right, but if we go ahead and plug that in, we can then see that we get y equals -132. So the 11th term would be -132. Let's do another one. All right, last one here. What is the 27th term in the arithmetic sequence? All right, 24, 19, 14, 19. Pause it. Try to do it on your own. All right, first find what is the increase or decrease each time. In this case, I am going down 5 every single time. Down 5. So our equation will begin as y equals -5x. Where would I begin? All right, what is term 0 in this case? Well, again, if I subtract 5, what minus 5 is 24? 29 minus 5 is 24. So I'm starting at a positive 29. Take the 27th term, plug it into our rule. So y equals -5 times 27 plus 29. All right? And then plug that into your calculator. You should find that y equals -106. And that would be our 27th term. What I want to do now is I want to take a moment to show you how you can check this in your calculator. You can take any rule whatsoever and you can plug it into your calculator. I'm going to go with this rule that I have right here. All right, which is y equals -5x plus 29, and I'm going to show you what it looks like. So grab a graphing calculator if you're doing this in a classroom. If you have one at home, great. If not, you can always check it out on my graphing calculators in my class. Now, I do apologize. This is just a picture of a graphing calculator. You will not be able to see a screen active. I'm going to kind of draw on the screen. But what I'd like you to do when you have an arithmetic rule is go to y equals. When you get to y equals, you should see y1 equals, y2 equals, and so on. That's what it'll look like. And you can plug in your rule. In this case, we're going to plug in -5x plus 29. You'll have to hit -5, x is over here, and then plus 29 in order to get that to work. All right? And when you do that, that's going to be our rule. And we can go somewhere really neat with this. We can go to our table. Now, table is in yellow, so again, you've got to hit second first, and then you can hit the graph button, and it will take you to the table, and I want to show you what that looks like. I'm going to clear our screen here. And in the table, when it comes up, you should see x, you should see y1, all right? And you'll see numbers. Mine happens to start with 0, 1, 2, 3, 4, and so on. Your table may start at a different point depending on where it was last time it was used. And that's okay. I'll show you where to start wherever you can if you want to. But as we look at this, mine right now says 29, 24, 19, 14, 9, and 4. Sorry if that's a little hard to read there or see. All right, and what I notice is this. My arithmetic sequence given to me was 24, 19, 14, 9. All right, and remember, this was term 1. So it should match x equals 1 in our table. So when I look at this piece of my table where x is 1, the first term, second term, third term, fourth term, I see that it matches the pattern given to me. 24, 19, 14, 9, 4. Therefore, I know that my equation, my rule is correct. This verifies it for me, but you have to make sure that you are looking at term 1 to match term 1. This is term 2, term 3, term 4. You've got to make sure you match those up. They always give you term 1. You can't make the mistake of thinking that they gave you term 0. All right, so that's a way to double check your rule. Now, in here, you can use your cursor over in this column here, and you can scroll down or up, depending on where your cursor's at, to get to the value you want. In fact, you could scroll all the way down. We wanted the 27th term. And you could scroll all the way down to 27 and see what the value of the 27th term is. What if you're the 108th term or something? Well, you could scroll all the way down to that, but if you don't want to scroll that far, you can use this button right here. Table set. TBL set means table set. So you'd have to hit second and then the window button, and that'll take you to the table setup. And I'll show you some things that are at the table setup here. In our table setup, you will see it'll say the words table setup at the top, but then it will have something that says TBL start. And it equals, and you can select any number. What will be there is where your cursor was last in the X column. So you could jump to any one you want. If you want the 108th term, you could put 108 here and go back to your table, and it will automatically jump you to 108 in the table. It's telling you where you want to start. So if you're checking it and it's way down below and you want to find out, is my rule right? You want to get back to term 1? Well, then simply come up to the TBL start and replace that with 1, and then go back to your table, and you'll be at 1 in the table. Another thing that you'll see that I just want to point out is the change in table. All right, once again, we get this delta symbol that means change in. All right, and so the change in table, in this case, it's equal to 1, which is what we want. That's how your X jumps. So my X's will jump by 1. I'm going to start at 1, and I'm going to jump by 1. So it'll go 1, 2, 3, 4 in my X column. If you need to ever go by decimals for something for a table, you can change that to 0.5, 0.2, 0.1, and then your table will go by decimal amounts. So it just gives you some things to think about on how to set up your table. All right, and that's how you can use your graphing calculator to check your answer. Come see me in class if you have more questions, and good luck.